But I want to get you up to date done today. It's full of 3 sections.
Can I say one thing really quickly?
Go for it.
One thing that you said at the very beginning of the quarter is that by the
Uh-huh.
end of the quarter, everyone will be like used to your accent and like it'll be
Yeah.
hard to tell. It's so difficult for I don't think I ever will because the way that you say kinda
Uh-huh.
sounds so much like kenna. So every time that you say it, I'm like, what? Yeah, that's me. And it like gets my attention. So
Oh, okay. Then it works, not intentionally, but I'll work with that.
every single time, like I'll be just like watching this and listening to you talk, and then you'll say kinda, and I'll be like, wait,
Was
yeah,
she talking
I'm
about?
here.
No.
It,
Are any of you willing to share what I also predicted? Is that some of you will hear a Scottish voice when you're doing your homework? Ah, not one of you is willing to. Oh, okay, Ian, are you nodding like that happens? Okay, it does go away, so don't worry about it. Okay, so these are the 3 guys that we are going to try and get done. And that means that all we've got left after this is Thursday. And I want to try, if I can, and to make Thursday for review for the final. So it's going to be a kind of turn up with whatever questions you've got, anything that you're unsure about. I'll try and fix that issue. And then you can just get back to studying on your own because, you know, your time's valuable. So I want to make sure that, especially Thursday, you just turn up and find out what you want to know, and I'll be here, and then we'll call it good. So here are the 3 sections. We're going to look at, the first one is going to be about solving quadratic equations, special kind, and a process called completing the square. And the second one is going to be using a guy called the quadratic formula to solve equations. And the third one is going to be about graphing quadratics and some applications. I think there are about 3 of them. So let's get started. I can do it here. Let's get started with 8.1. Well, here is a quadratic equation. A quadratic equation is any equation where the highest power of x is x squared. That's an example of a quadratic equation. There are a number of ways you can solve it. This particular one, I would probably factor out a common factor of x. And then I could just basically say either that is 0 or this is 0. And that would be my 2 solutions. And that would be the end of that question. You can, however, get quadratic equations that have this shape to them. Something with an x squared equals a number. Now, there are a couple of ways that you're going to solve that, but the one we're going to focus on is basically a technique that we've used for many other situations. As long as there is no x term, right? As long as it's just x squared on one side, a number on the other, as long as there's no x terms, this technique will work. And the method I'm going to use is as long as you do it to both sides, it's okay rule. You know, I use that a lot. Okay, what do you think might be a good idea to do to both sides in this equation?
Square root.
A bit louder. Didn't quite catch that.
Take the square root.
Not yet, but that will happen. What do you think you might do just before you do the square root thing? Yeah.
Divide by 2.
Okay, so you divide both sides by 2. And then you take the square root of both sides. And here's something a lot of people forget, and sometimes I forget as well. When you take the square root of both sides, you actually generate 2 possible answers. It could be the positive square root and or it could be the negative square root. Because typically, quadratic equations with x squared in them, have 2 solutions, typically. There are some exceptions. Now, I'll take this fella, and then I'll take this fella. And you might say, well, can't I just leave it like that? Well, I wish you could, but you're not allowed to. You're meant to try and get the answer in its simplest form. So, let's do the positive one. You can split this up into 2 square roots. And do you know, in this particular case, the square root of 9 is 3. And then on the bottom, you've got square root of 2. And that's considered better. But we can do one more thing to make it even better. There's a rule that says we do not like fractions with square roots on the bottom. And because of that math rule, I call it style points, to make it look pretty, we fix it. And the way that you fix this is by multiplying by a special version of 1. Square root of 2 over square root of 2. Would you agree that's a fancy version of 1? Well, let's see what that does. You get 3 times the square root of 2 over 2. You are now finished. I could go through the entire process here, but can I just cut to the chase? I don't think it would surprise you too much that the second answer is basically the same number, but the negative of it. So we are going to look at solving quadratic equations that have this basic shape, right? So many x squared equals a number, right? And we're going to do it by, as long as you do it to both sides, it's okay rule. Let's try another one. I haven't really changed anything except the numbers, right? So the process should be the same. We think we're going to do it to both sides.
Divide by
First. Yeah. Now, would you agree in this particular question, it's going to come out much nicer than it did the first time, right? So sometimes you get easy ones. So when I take the square root of both sides, and don't forget the plus minus. In this case, I think I'll keep it together. Would you agree x plus or minus 2? You may have to, I honestly can't remember, you may have to put in, 2 separate answers like that. And the WebAssign homework might not let you be able to type that. I'm not even sure if you can type that in as a button. So you probably have to split it, right? Big one, low one, something like that. We're getting a bit more comfortable about this particular subgroup of quadratics.
Why did you put the square root of 2 instead of just 2?
Oh, goodness gracious me. Did you all catch that deliberate mistake? Yeah, I don't know why I put 2. I think I just wasn't paying attention properly. Now, same question, a little bit harder. 2x squared plus 7 equals 23. Still trying to find x. Still trying to solve it. What should I do first to both sides?
Subtract 7.
Right? What should I do next?
Square 16.
Not yet. Hold up. Thought. Not yet.
Divide by 2. Right. I missed that.
Right. And now you can take the square root. Always looking for style points. Always looking for different ways in which to write the answer down, right? Would you agree that the square root of 8 can be simplified? Forget about the plus minus. 4 times 2, which becomes 2 root 2. So your answer will be that guy. Or more likely, 2 distinct answers written out separately. But that's the same thing, right? We good? Okay. How about really not that much different. Just a matter of knowing what to do first, what to do second, and what to finish with, right? So what do we do first?
Add 6.
You agree you then divide by 3? And then you can take the square roots. Just to save some time, I'm not going to split these guys into 2. You can imagine what they would be. Can you do anything to the square root of 5, or is that as good as that's ever going to be? Can you do anything more to the square root of 5? Mark's shaking his head correctly. Nope, you can't. Right, that's as good as it's going to be. So you're going to have to be on the lookout for when it can be, made a little bit prettier, and when you can't do anything to it. We're comfortable with that particular subgroup of quadratics. It has x squareds in numbers, nothing else, just x squareds in numbers in various places. Now, let's look at quadratic equations that look like this fella. X take away 2 squared equals 9. And I'm still going to do that as long as you do it to both sides, it's okay rule. What would be, in this question, what would be the first thing I need to do? What would be the first thing I should do? I'll bring this back in a second. I'll just put you on. What should be the first thing I should do here?
Take the square root.
Yeah. Yeah. Do you see how up here it was add and divide and then the square root was the last thing? Do you see in this question it's the square root is actually the first thing? It depends on what you've got, what you do first. Now, if I take the square root of both sides, well, you also remember to do a plus minus. So we're kind of at this step here. And in these questions, you really do have to separate them. So we're going to have x minus 2 is negative 3, and then x minus 2 equals positive 3. So we're at this stage. We're one line off the 2 solutions. X subtract 2 is equal to negative 3. What should I do to both sides to find x?
Add 2.
Which gives you the answer. And then wouldn't you also add 2 to get you this answer? Do you see in this case, the 2 answers aren't plus and minuses of each other? Right? Do you see in this case, aren't the 2 answers quite distinct numbers? Right? They're not really plus or minus, they're just quite different from each other. No, don't like 6. Yeah, I like that better. Okay. I'm just rewriting this question. I don't like marks that distract me. Right, that's the question. You got to do something first, you got to do something second, and so on until it's finished. And you have to kind of know what the order is. In this question here, you kind of start on the outside and then you should try and work eventually to the inside. So I look at that plus 3 as my first target. And so I'll subtract 3 from both sides. And that seemed like a good strategy. Every time I do something, it should get nicer, right? Simpler. Now, when I look at this, do you see the 2 is the next guy to leave the room, right? I'm going to get rid of that 2. And I'm going to do that by dividing both sides by 2. So when you do these questions, eventually you get to a line that looks like this. Something squared equals a number. In this case here, right, the something squared is that, and the number is 3. So to get rid of the square, you take the square root of both sides. Now that is going to make this answer, this answer look kind of weird. One of them is that, and the other is that. Right, x minus 1 plus or minus root 3. There's the negative root 3, there's the positive root 3. You just got to live with ugliness, right? Don't let it bug you. What do you think I need to do to finish this question off? What should I do to both sides? Okay, now I would put the 1 at the front. It just, to me, it looks nicer. And here are your 2 solutions. So far, so good. So we have, I guess what we've been solving some special quadratic equations. The theme seems to be something squared with some numbers, right? Either things that look like this or more complicated things that look like that. But mathematically, they're not that different from each other. And we certainly solved it the same way, didn't we? Just do things to both sides to eventually get x. Okay. If you feel comfortable with that, I'm going to leave that. I was just checking the homework questions in case there's something, a situation that I've kind of overlooked. Are we happy about this type of group of questions? Do I need to give you some examples to feel comfortable, or do you want me to move on? Do you want to try maybe one of each just to feel that you know what's happening, or are you okay with us just moving on? We got a thumbs up from one of you. Anybody going to do a thumbs down? No, 2 thumbs up. I guess in a democracy we'll call that a majority vote. Okay. So the next thing we are going to do is called completing the square. It is a very, it's a very algebraic process. And when you see it at the beginning, it's going to look a bit weird. And maybe it'll take me 3 or 4 of them before it stops looking weird. Right, so you're just going to have to think about it as we do some examples. Essentially what we're going to do, well, let's start off with a simple case. Some quadratics are perfect squares. Here is an example of one. Would you agree that the 2 numbers that you use are both plus 3? And that this is called x plus 3 squared. So we would call this particular quadratic, this whole thing, we would call this a perfect square. It would be nice if every quadratic in the universe was a perfect square, because it would actually be a lot easier to deal with algebraically, but they're not. So what we do is we try and get it as close to this fella as possible. And that process of taking a normal quadratic, right, with 3 terms and making it look more like a square thing, a perfect square thing, is called completing the square. So here is a random example. That is a quadratic expression, right? Now, this is how you will do the process. I'm going to write a little sentence down. This is the magic. Half the number of x's square and subtract. This is the process that will allow you to do what's called completing the square to any basic quadratic that starts with x squared. Right, as long as it's got a leading coefficient of 1 in the x squared, you're good. Well, let's try this fella. Do you see that guy there? That's the number of x's, isn't it? There's 8 of them. So half the number of x's is 4. So you will call it x plus 4. That's half the number of x's. Square that number and subtract. Half the number of x's, square that number and subtract. Which means that we get that. And this expression is the same thing as that guy. You don't believe me, multiply that out the usual way and you end up with that. This weird looking guy, that's the guy that we call the completed square form. Now, we haven't given you any justification of why we would want to take this guy and make him that. But for the time being, will you just hold on to the thought that you don't need to know why yet? You'll see later a reason why that's useful. But right now, we're just going to get good at completing the square. So I'm counting that guy as my first example. I'm going to do 2 more, and I'm making a prediction, which might not be true, but I hope it is. I did 1, and you're thinking, what the heck's he doing? I'll do a second one, and you'll say, I think I know what he's doing. I'll do a third one, and hopefully by then, I know what he's doing. Now, you don't need to understand why he's doing it, you just understand what I'm doing. So here's the next fella. X squared plus 10x plus 3. Okay. Half the number of x's. Can you see where the 5's coming from? Half the number of x's. What do I do with that 5? Square it and subtract. Isn't 5 squared 25 and then you subtract it? That gives me this fella. You've now completed the square. You have no idea yet why you want to do that, but can you do it? Are you beginning to see where I'm getting the numbers to make this happen from? Try another one. Okay. What number's going to go here?
6.
Okay. So you know how that happened, right? Now, what do I do with that 6? I square it and subtract. Which means that I now have that guy. I've now got the completed square form. Half the number of x's, square it and subtract. Now, it's very cryptic, but I think it essentially tells you the process, doesn't it? Half the number of x's, square it and subtract. Think of that as a little mantra that you say to yourself, right? Now, I've tried to keep these three questions simple. I've made these numbers positive and easy to half. That last number was just random, right? Same process, just going to make it a bit messier. I'm going to change the letter, which I hope isn't a big problem. And I'm going to make it -8 instead of typical plus. Okay, so we're going to adapt. What number goes next to the b in the brackets?
4.
What kind of 4?
Negative.
Agreed. Now be careful about this. You got the number. Isn't the next step square it and subtract? Be careful. What do you get if you square -4? What number do you get if you square -4?
Positive 16.
You might have, I didn't catch it. You probably was right. What did you say, Mark?
Positive 16.
Right. So do you see that you get 16 and then you subtract? Have you noticed that it doesn't matter if that's plus or minus, you always end up subtracting according to this? Half the number of b's, square it and subtract. Make it look pretty. How about this fella? Now that one's going to definitely test you. Okay. What'd you get if you half that guy? Half that guy.
Three-fourths.
If you square it, don't you get 9/16? Right, 3/4 squared. And what do you do with that? You square it and subtract, which means you get one of the ugliest looking answers I could come up with. I believe that's 4, that's 9, so it's -5/16. That is completed square form. Half the number of x's, square that number and subtract. Half the number of x's, square and subtract. I'm going to give you something to try. A couple of easy ones, a hard one or two, and then a stinker that you've never seen to see if you can adapt. So these first two, 1, 2, 3, 4, should be pretty easy. I'm home. Whoops. Okay, see how many you can do in 3 minutes. Okay, let's go for it. Anybody want to go through the first one?
X plus 5 squared minus 24.
Okay, and what you said was exactly correct. So that's the first answer. Great. I'll do this one then. Half the number, take away 16. So b take away 4 squared minus 8. That look good. Right. And this one here is a stinker. I think I'm going to put the answer here because I probably need more room. Don't you have to half this guy? So what's going to go in here? From here, what goes here? Whoops, just realized I changed the variables. Anybody got a choice? Bit louder?
3/2.
Okay. And doesn't that mean you subtract 9/4? And a kind of lucky coincidence, don't you just get the square part? Which, by the way, doesn't that make this a perfect square? Doesn't happen often, but it's nice when it does. This one here, I guess I'll put it here. Okay. What goes here next to the c plus?
1/2.
Okay. And then you subtract a half squared, which is a quarter. So I guess you're going to have c plus a half squared, what, plus 3/4? That's going to be c. Okay, the worst of the set, I think. What's the number that's going to go inside the brackets next to this negative sign? It's actually a fraction. So what goes there?
3/8.
Now, if you square 3/8, I believe you get that ridiculously ugly fraction. And then you might want to work on it, but that guy there is 4/64 added to 9/64, so you get negative 13/64. Do you feel comfortable about this process called completing the square? You might not know why you want to do it, but you can do it. Right. So let me show you why you might want to do it. Or it will a few minutes from now. Before I get to that point, let's get some things out of the way. If you write down a quadratic equation so that it has that form, you know, like 3x squared plus 2x plus 7 equals 0, we say that this equation is a standard form. So, for what's about to happen for the rest of this section, we want to see all quadratics looking like this. If they're already looking like that, great. If they're not, you have to make them look like that before you start this completing the square process. Because we are going to solve these quadratic equations, right, using completing the square process. So typically A is going to be 1. So we'll leave it at that. So suppose it was x squared plus 4x plus 1 equals 0. Now, normally what you would try to do with an equation that's quadratic is when you try and factor it and then get the solution. Do you know if you try to factor this, it ain't going to happen? Would you agree? Just ain't going to happen. There's not a factor in the world that you could factor that quadratic. A lot of quadratics don't factor, so that's why we need this weird process, right? So, complete the square. Half the number of x's, square and subtract. That now leads us to there. So do you see what I've done is I've taken this guy and converted it into his completed the square form. Now you think, well, what use is that? Watch, it's cool. Can't I add 3 to both sides? Now, as long as you do it to both sides, it's okay, rule. What should I now do to both sides? In fact, we did one earlier today, not unlike this. What do you do to both sides to get it next step? You may have said it, but I couldn't hear you if you did.
Square root.
Okay. So when you take the square root of both sides, remember that plus minus thing? Because you know there are going to be two answers typically. So here are our choices. One of them looks like that, right? And the other is going to, look like this. Subtract 2 from both sides. Subtract 2 from both sides. There is the solutions to this quadratic equation. Now, do you see how ugly those solutions are? These are exact values, right? These aren't rounded off decimals. This is exactly what it's equal to. Do you see that we now have a process where we can essentially solve any quadratic equation as long as it is doable, right? As long as it's got a solution. You see, completing the square is going to work, right? This process can be done to almost anything. We good? Show you another one. Okay, there's a quadratic equation in its standard form. So now we can do completing the square. Half the number of x's. Square and subtract. You see, it's very like this line, isn't it? Very similar looking. Okay. What should I do to both sides next?
Add 19.
Okay. You see, looks like my dog wants a cuddle. I'll give him one in a second. You got this thing here? Right. Can you see where we're off to next? Because there's a kind of flow to this, isn't it? You do this, then you do this, and then you do this, right? This goes like 1, 2, 3. What's kind of step 2 then? From here to the next line. What do you do?
Take the square root.
Okay. With a little plus minus. See, I was pointing over here trying to show you, look, isn't that exactly what you did here? Same kind of situation, different numbers, right? That's what I'm trying to do. So that's going to give me the negative version of this guy, and over here, it's going to give me the positive version of this guy. And then add 4 to both sides. And there's one of your answers. And add 4 to both sides. And there's your second answer. Do you see this process is quite mechanical? Because if you know how to complete the square, aren't you going to end up with a line that looks like that? And then you finish with the usual way. So it's not intuitive. It's not maybe for your brain's thinking, what am I actually doing here? But the plus side is it works, doesn't it? It allows you to get solutions to quadratic equations that you cannot factor and couldn't really figure out up until now anyway, a way to do this. Okay, let's move up the food chain, make it a bit harder. Right now it is in its standard form, so it's good to go. Right, just doing all the stuff that's not going to change. Agree you half the number of x's. If you square that guy, you get 9 quarters, right? Negative 3/2 squared is 9 quarters. You subtract that 9 quarters. So it's going to be left That guy is 8/4. Take away that guy. You can check it later, but it is -1/4. 2 whole amounts subtract 9/4 result -1/4. Add 1/4 to both sides. Point here again, right? You see where we're going? Take square root of both sides. And now it's time to do the two versions, the two solutions that you're going to get. I think I could do this in one go. Isn't the square root of 1/4 actually quite a nice answer? Square root of 1/4, isn't it a half? Right? So it's going to be -1/2 or +1/2, right? If you add 3 halves to both sides, you get 2 halves, which is 1. And if you add it again to both sides, you get 4 halves, which is 2. Can you see that you even get solutions that are nice sometimes? They don't always have to be this weird thing going on here. They can be quite different and quite nice. Do you feel you've got the process of how to take this guy and use the completing square trick to solve pretty much any quadratic equation you like? This has an advantage over factoring. By the way, this one factors, right? But doesn't this technique have an advantage over factoring in that it'll work even when it can't be factored, right? And this can't be factored, but it still gets you an answer. Factoring is a really good technique, but it can only be used, sparingly, right? There are only certain combinations that work. This doesn't care. Won't this method get you the answer no matter how ugly I make these numbers? No matter how weird they are? I can even stick fractions in, right? It won't matter one darn thing. This technique will get you to the end. And it's all to do with the fact that completing the square process allows us to solve it, doesn't it? That's kind of the trick. Completing the square makes it happen. So what do you think is going to happen? When an equation is written like that? Because it's not in its standard form. Shouldn't it be quadratic equals 0? So if I'm going to use this technique, I can only use it when the guy that I've got ends up looking like this. So you may have to do that to it. Great. Now, this question here, I'm not doing it, but couldn't we complete the square and solve it just like we did all the others? Another situation then. Suppose you were being asked to solve that quadratic equation. Very similar problem than this one, isn't it? That is not standard form. It's not a complete quadratic equals 0, right? It's guys all over the place. So I guess the first step should be to make it look proper, right? Make it standard form. Okay, what could I do to both sides to make that happen? What could I do to both sides to make this one eventually looks more like this?
Add 6b and add 4.
Now, can I just dot that? Because isn't that just a classic completing the square method and off you go and you get your answer? Suppose I have a question. And it looks like that. It, technically speaking, isn't it in its standard form? Great. Quadratic equals 0. Big difference. You see how that's 2b squared? 2. We call that the leading coefficient, right? It's 2. When you got that guy, don't we want this guy to be 1? Because the completing square assumes that you've got x squared or b squared or whatever the variable is. I don't have that yet. Okay, but I can fix that. As long as you do it to both sides, it's okay, Ro. Give me something to do to both sides that's going to make that easier to work with.
Divide by 2.
Now, if you divide 0 by 2, it's still 0, so there's no problem. Would you agree that guy is a great candidate for completing the square? And boom, off you go and do what you need to do. Okay. I think I'll just give you 2 of these, and if we're comfortable with them, I'm going to go and look at the homework and we'll do a quick scan in case there's something there that I've missed or something there that you don't feel comfortable with. And if that works out well, which I hope it does, we'll call that 8-1 finished. So. Okay, there's the first one. Oops, I'll need more room than that. Here's the second one. There's your second one. Okay, go for it. A minute each, 2 minutes. Okay, let's go for this fella. Already in standard form, half the number of x's, which is 5, square it and subtract. Should have been your first line. That then becomes that guy, right? Then you add 5 to both sides. And then you take the square root of both sides. And since I don't have a lot of room, I'll just go cut to the chase. I believe you get -5, take away the square root of 5. And the other choice is -5 plus the square root of 5. Does that look good? Okay. This one here had a little chaser, a little kick in the tail first, right? Because I shouldn't try and complete the square yet. Shouldn't we get rid of the 2 thing? We talked about that in an earlier question. So divide everybody by 2. Now I can complete the square. Half that number, square it and subtract. We're good. Right, where are we off to next? Well, how about add 12 to both sides? And then take the square root of both sides. And that eventually gets you -4, take away the square root of 12, and -4 plus the square root of 12. Is that as good as that answer can be? Correct. Can't you do a little to make the square root of 12 a little bit prettier? I believe it comes into 2√3, 4 times 3. So -4, take away 2√3, and -4, add 2√3. Looking good? Right. So what I'm going to do now is
I had a question.
yes.
So not on these two, but on the one example you wrote down before that, doesn't that give you a complex number?
This one here?
Yeah.
Yes, it will. But don't worry, none of your homework questions have complex numbers in them. So
Okay.
that was just a randomness of the digits, right? But you're right, that would end up being a complex number. Not that that's that bad. It just means your answer will be things like, well, I can't remember what it would be, like 2 plus I and 2 minus I. You know, I'll have that kind of look to it. And it's correct, but you're not going to be given that kind of question. So we're not going to be too, yeah. But it was, yeah, well caught. That's correct. I might have had another one there. I wasn't intending that to happen. But if I did, the process is still going to do it. Right, well, let's kick over to see what kind of things are going on in the homework and see if I've missed anything, and if things are good, I think we'll have our first break. That is not what I wanted to do. Let's try that again. Are you looking at screen 2? Are you looking at the formula? Because it's hard for me to tell. Are you seeing the homework number 8.1? Okay, for whatever reason, I screwed up. Right. I've got the answers here. It just makes life a little bit easier. This is called a quadratic equation. This guy's a perfect square. What you're meant to do here, I don't know, the answers are actually more of a distraction than a help. But if you factor these guys, they end up being perfect squares. Right. This question here, how many solutions are represented here? The answer is there's 2. Can you see you get -27 plus √3/17 and then -27 take away root 3 over 17. And that's what they would look like if you wrote them in full. And if you took this mess, it would be that decimal. And if you took this mess and done it in your calculator, you get this decimal. So, and then we move on to these guys. These were the first kind I did today. Can you imagine what that would look like on working? X squared equals 38, right, if you add 38 to both sides. And then can you see that you just do a plus and minus? It looks like the way they want the answer is you type in the square root of 38. Actually, you type in the -1 first, it looks like, but that shouldn't really bother it. And then you just basically put a comma and you type in your second one. So that's how they're going to do the two answers, right? Instead of x equals and then another box, x equals, they're just having a single x equals with two numbers with a comma between them, right? So that's just going to be the format. Are we comfortable with that? Can you imagine doing question 8 the same way we do question 7? Can you imagine doing question 9 the same way? Okay, the answers here are a distraction. I've changed my mind. They're not helping me. They're kind of cluttering up the question because it's hard to tell what the question is when the answer is in front of you. Why is that jumping off and on there? Okay, so much better. So can you imagine question 9? If you solved it, one of these guys would be your right answer and you just pick it. So that's a slightly different way of doing it. But if you were doing this question, wouldn't the first step be to add 63 to both sides? So it'd be z squared equals 63. And then if you do that, I'm assuming that 63 simplifies. Does anybody know how it simplifies? Because it does. How does 63 simplify? There's a perfect square in there somewhere if you go hunting for it.
3 square root 7.
Yeah, so it's 9 times 7, which gets you 3 root 7. If you were going to do question 10, right, this one here, wouldn't you add 16 to both sides and then divide both sides by 5 and then square root it? So it'd be a 3-step process. Add 16 to both sides. Once you've done that, you'll have 5x squared equals 16. Then you would divide both sides by 5. So that would be x squared is 16/5. And then you can do the square root thing and you're done. We did questions like 11 and 12 and 13 and 14. Oh, this is a little bit different. Question 15. F of x equals x plus 2. I'm going to write this guy down. Is x plus 2 squared. And you're trying to find out when f of x is equal to 2. And the one after that, I'm going to look at 16, which is 7a take away 5 squared. And you're being told that g of a is 27. Okay. I didn't do ones like that. So since these questions tend to vary with the numbers, but not the question, here we go. That's f of x, that's just function notation. And f of x is 2. When you put these together, you're trying to solve when is x plus 2 squared equals 2. Do you see how it works now? Now this fella here, you're trying to find out when that guy equals 27. Oh, this is a good one. I'm going to do this one. You know, it's pretty much ready to go, isn't it? I don't need to rearrange anything or foil anything out. What do I do to both sides? I think your dog wants some attention, Scully. Okay. What do you do to both sides?
square root.
That's what I'm looking for, yeah. And you get a plus or minus. I think I'll fix this guy right now. Square root of 27 simplifies. Isn't it 9 times 3? And 9 times 3 gets you 3 root 3. That means I have two different looking solutions. One of them looks like that, and the other looks like that. Okay, I can handle that. Do not let how ugly these things look distract you from the process. I don't care if that's 3, 0, or some ugly fraction I've never seen in my life. I'm still going to do the same thing regardless. Wouldn't my next step be to add 5 to both sides? If you add 5 to both sides, does that. What's my last step? What do I do to both sides?
Divide by 7.
And can I just cut to the chase here? After a while, the two answers, although they are different, aren't they very similar? Don't they typically have the same numbers and the same things, just one is a plus and the other is a minus? So normally if you can get one side done, you can pretty much figure out what the other side is without going through all the steps again. Okay, you feel comfortable about that, guy? Right. Let's return to the homework, because the reason I did that was just to cover any little gaps in what I've done. Okay. Complete the square, right? Half the number of A's, square and subtract. Oh, there isn't a number there. Doesn't matter. Don't you still half the number of X's, square and subtract, or half the number of B's, or whatever letter it is? Do it with that one. Do it with that one. Can you see how we finished today by completing the square technique for solving these guys? That was kind of the last thing we did today. So complete the square equals 0 and then solve it. And the last question, yikes, complete the square and solve it. And that's it. That's 8-1 done. I'll see you back in 10 minutes. Have a nice break. And we'll be ready for section 2, hopefully. Hi, Evan. How are things?
Oh, things are going pretty good.
Good. I don't know if you've ever told me. If you have, I've forgotten. Do you take any other classes during the summer?
Oh yeah, public speaking and technical writing.
Public speaking is a little bit hard when there's no public. So how did they work that one out?
We just had to give speeches over Zoom meetings, which honestly for me was probably preferable instead of having to get up in front of a bunch of people.
Easier to do a speech when you're not physically there?
Exactly.
Okay. And technical writing? Is that the third one?
Yes.
Yeah. You know, you're going to go you're engineering, science, computer-y kind of person then?
Yes, exactly.
Okay. Good luck to you. I've never found anything in English interesting, and I think technical writing would probably be close to the most boringest topic I could imagine taking. But that's just me. Don't tell your English professor I said that, because they would probably say the same about math.
As long as
Is it?
two of us, I agree with that.
Okay, so I'm not. Hannah, you're smiling like you've taken that class and you think, yeah, it's pretty boring.
No, honestly, I only heard half of the conversation.
Oh, you're just happy then. Okay.
Yeah.
Oh, we were just talking about technical drawing and not technical drawing. What's it called? Give me the Evan. What's that class called again? I've forgotten its name. Technical writing. Yeah. So we were doing technical writing, and I was just saying it was really boring. Mark was smiling, so I'm assuming he was agreeing with me, and you were just smiling because you were happy.
No, I'm laughing because technical writing is like one of the few English courses I do like because it's not subjective at all.
Ah. Okay. I can understand that. That's the thing I didn't like about English was how subjective.
Technical writing is actually my job.
Oh God! If you're going to put your foot in it, you might as well just go jump both feet in, right? Just go for it. So that's what you do. Do you write or help to write manuals for things and so on? Is that the kind of
Yeah,
job?
that's exactly what I do.
Oh, you want to share? Who do you do it for? Do you do it for a company that just specializes in that, or are you in just one company?
It's for a technology company.
Okay.
It's actually right over on the Keyport base.
Okay. So don't share this if it's secret, and I don't need to know, but does that also involve things like when you're on submarines, you get a manual that says, if this green light goes on and that red light goes on, run away really quickly? Is it one of those manuals?
Basically.
Okay. I hope they don't have, if this green light goes on and this red light goes on at the same time, run away really quickly.
Well, that exists.
Does it? They have one that says pretty much that. I hope they don't do that on your first day, because you probably quit. You know, what am I going to do if this competition happens? Yeah, okay. So why are you doing, Jennifer, why are you doing Math 99? Is it because you're getting your AA and it's your pathway to getting your math thing done?
Basically, I'm trying to work on a bachelor's right now. I'm going to get a bachelor's in business or communication.
Okay. So this is for your math box. You do 99 and then you're going to finish with 141, 107, something like that, maybe even 146. Yep. Which one are you finishing with? Do you know?
It's looking like 107 right now.
Okay. So why are you doing Math 99, Hannah? If you want to share.
Because I need it to get into a certain chemistry class that I need, because I didn't place high enough on the AccuPlacer, and I need the chemistry class for the nursing program.
Right, so your goal, based on what you've just told me, after you get 99, you're probably going to do Interrelated Stats.
Yeah, that's the plan.
Yeah, that's typical nursing pathway. That's what they, a lot of them, not saying everyone does it, but a lot of them, that's the way they go.
Yeah.
What about you, Brittany? Why are you doing 99?
I'm thinking about being a dental hygienist. So I basically have to do the same prerequisites as the nursing program.
Okay, so if you're in the medical field, a lot of you kind of go that same route. Makes sense.
Yeah. But I think I'm just going to do the AA while I'm at it, because it's close enough.
Okay. Do we do a dental hygienist program? Because I don't think we do. I know we do a physio and I know we do nursing.
No, you have to transfer.
Right. Do we do any other medical classes here? I mean, career-wise, is that the two major ones?
Physical therapy.
Physical therapy, right, and then nursing. That's the two. Okay. Well, let's get started on our second one of the three. We'll see if our brains, or if my brains can hold up for it. Using the quadratic formula to solve quadratic equations. So we're going to solve quadratic equations again, and we might end up solving the same quadratic equations, but using a different technique, and it's called the quadratic formula. So let's start by telling you that if you're going to use the quadratic formula, your equation has to be written in its standard form, which is essentially what you need to do if you want to do completing the square, right? Everything equals 0 is kind of your starting point, right? Now, from here, I'll give you an example. 3x squared plus 4x. What? Oh, I apologize. Evidently, the kids want a poo walk, so I shall be back really quickly. Okay, come on, let's go. Come on. Okay, we are ready to go here. So this is an example of a quadratic equation. A would be 3 in this example, B would be 4, and C would be the number 7. So one of the first little things you have to be able to do is identify who A, B, and C are going to be. A is basically how many x squared you have, the number B is how many x's you have, and the number C is the constant term, right? The one that has no x's attached to it. That is a formula called, not surprisingly, quadratic formula. And it looks like this. Not a very pretty formula. But aren't formulas just plug and chug? You put the numbers in and you get the answer. Even the ugliest looking formula in the world is basically that. So we are probably going to spend a fair amount of our workload is going to be done using the calculator, right? So since I've got this one set up, let's solve it. So you begin with the equation written in its standard form. You identify who A, B, and C are. I do not typically do this equation in one go. And the reason I don't do it in one go is there's just too much going on. And if you try and do it in one big, horrible calculation, even if you use your calculator, do you know you're probably going to forget a bracket somewhere or forget something somewhere else, and it, you know, it just falls apart. Too much going on. So what I do instead is I break it into manageable chunks. Do you see this bit inside the square root? The b squared minus 4ac fella? I calculate him first. So he's going to be 4 squared, take away 4 times 3 times negative 7. So let's see what that guy looks like. 4 squared, subtract 4 times 3 times negative 7. Now, if you look really, really carefully, do you see the negative 7 has a tiny little minus on it, and the subtract has a big little minus on it? If you get an error, it means you've used the subtract button when you should have used the negative button. Now, when I hit enter, I get 100, which is nice. So that's step 1. This guy is used a lot. You know this b squared minus 4ac? It even has a name. That piece of the formula is called the discriminant. So if you ever see that term, that's what they're talking about. Once I get that guy, I can then tackle the whole formula. It's going to be negative b, take away the square root of b squared minus 4ac all over 2a. And the other one's going to be negative b plus the square root of b squared take away 4ac all over 2a. Right. Negative b becomes negative 4. Take away the square root of 100, all divided by 2 times 3. Now, that calculation is manageable on my calculator. And then once I've got that answer, I'll go back to this one and get the second solution. So let's look at this one first. See if I can put it in a way that we can see it written on the calculator at the same time. There we go. Now I'm going to do this wrong, so don't hit anything. It's going to look right, but it's wrong. Okay, I'm kind of warning you up front. Well, it looks pretty obvious to me. You go negative 4, you subtract the square root of 100, which I guess I could have done in my head and call 10, but too late now. So that's the top. And then you divide it by 6, because at 2 times 3 I can do in my head, right? Doesn't that look right? I mean, it looks like it's the correct calculation. And you'll get an answer, and that answer will be wrong. So here is the right order, bracket, negative 4, take away the square root of 100. Close the brackets, divided by 6. Did I do that right? Oops. I just did it wrong again. Bracket, negative 4, take away the square root. I forgot the square root had a bracket in it, so I needed to finish that second bracket. Now I can do it. There we go. That's the answer. That's the right one. So what was the problem? The problem is that you need to put brackets around the top. Now, as a decimal, the answer is what, negative 2.3? Let's show you what it looks like in this case. We want to be negative 4 take away 10 over 6. And won't that get me negative 14 over 6? And can you see where the negative 2.333 came from? And this one, well, it's going to be negative 4. Add the square root of 100 over 2 times 3. That's going to be negative 4 plus 10 over 6. That's going to be get me 6 over 6. That's going to get me 1. So our two answers. Oh, I just realized something. Forget the decimal value. Can I simplify negative 14/6? Agreed? Can you get negative 7/3? So a big problem is that calculators tend to give you horrible decimals. Agreed? Watch this. I'm going to hit math button. Number 1, answer. Do you see that? Horrible decimal, -2 point lots of threes, math button, number 1, and basically what this does is it allows you to take your answer and convert it into a fraction. So you see that you can actually use your calculator to get you the -7/3. Now, the calculator is totally fine with whole numbers, right? If the answer's 4, it'll tell you 4. But it's going to tell you 4.25 when you probably want a fraction. So every question every question I'm about to do is going to use the quadratic formula. So here's my next guy. This guy is going to be ugly. A is 2, B is equal to 3, and C is -8. So I'm going to find the B squared take away 4AC part. That's going to be 3 squared take away 4 times 2 times -8. That's going to be 9 add 64, and that's going to be, I believe, 73. And you can use your calculator a little bit for that. The quadratic formula is -b plus or minus the square root of 73 all over 2a. Do you see I've just put in the numbers now? But what we got is our two guys. Well, we have -3 plus or minus the square root of 73 divided by 2 lots of 2, which is 4. Now, if I want exact values, all I really do is suck out the 2 ugly answers. And here is our solution. Now, if the book wants the answer to decimal places, you can imagine you could use your calculator to do that. If it wants exact values, you probably shouldn't use your calculator much, because in this case, the fraction button won't help, because that's not a perfect fraction, it's got a radical in it. I'll show you one that's uglier than even that. And this one is actually from the homework. Pretty much the same question every time. Solve these guys' quadratic equations, right? Am I ready to use that, or do I have to figure out a better version of what that looks like? Is that ready to use, or do I have to fix it?
Add 1.
Okay. Now, that makes this guy A equals 7, B equals 9, C equals 1. Okay. The B squared take away 4AC part becomes 9 squared take away 4 times 7 times 1. That's 81 take away 28. I'm not going to risk that. 81 take away 28. Looks like we're getting 53. So my solution is going to be x equals -b plus or minus the square root of 53 over 2a. Do you see, because of the way I did it, hasn't this formula became at least manageable? It's not too much happening at once. I would say anyway, that's what is happening here. So negative of b plus or minus the square root of 53 over 2 times 7 gets you 14. And pretty much we're finished. All I'm doing is separating them into their 2 pieces. What you're probably going to find is that you put a little comma around them, and that's what it looks like when you do it in the homework. If they said, give me the answer to 2 decimal places, don't you then just go to the calculator and put the brackets like I did at the start, and you write 1.23 and minus 5.97, whatever it is. Now, the cool thing about quadratic formula is that every question, in my opinion, every question is the same question. You just have different numbers, right? Go through it the same way, different numbers. So to convince me that that's actually the case, let's give you 2 to try. If you can do these 2, I think we should be fine. I'm going to ask you to do these questions, and I want you to give me the answers in exact form. That means like this, right, with square roots and whatever. So, first one is going to be 2x squared minus 6x plus 1 equals 0. And the second one is going to be 3x squared equals 2x plus 10. Okay. Give you 5 minutes. Go for it. 2.5 minutes each. And the gun has fired. To me, that's the basic template for every one of these questions. Come on, boy. Come here. He's a good boy. Come here, baby. Oh, there you go. Come here. Yes. Oh, he's a good boy. You want up? Okay. Come here. Up, sit, Izzy. And up. Oh, there you go. Oops. What's up? Oh. Good boy. I know. Yes, you are. Good boy. Yes, a good boy. You go and see Mummy now. Come on. Let's go. Look, come on. Let's go. Come on. Come on. I think we'll finish at this point. Hopefully you've time to do at least one, if not both. Right, in this case, A is 2, B is -6, C is 1. So what we're looking at is -6 squared, take away 4 times 2 times 1. Hopefully you know that -6 squared is positive 36, and then you take away 8. So I believe that is 28. That look right? 28? Got an odd sign. Okay. So over here it's going to be negative b plus or minus, I guess, the square root of 28 over 2a. What number do you get when you take the negative of -6? So what do you get if you take negative b, right? The negative of -6.
6.
You get 6. Don't plus and minus the square root of 28. Can the square root of 28 be made to look nicer? Can you simplify the square root of 28? Yeah? 4 times 7, which gets you 2 root 7. So I'm going to turn that into 2 root 7. And then let's see what our two answers look like. Well, I'll put one of them in because I don't think I've got enough room for both. Won't one of them look like that? Agreed? Can you do anything to this to make it a little bit nicer? Can you see anything to do with this weird thing to make it look nicer? Divide top and bottom by 2. And that would be one of the answers. I think the other should end up something like that, right? Let's move on to the second and final one. A is 3, B is 2. Yes.
So when you got x equals b minus 2 square root 7, how did you know it was going to be a negative?
I didn't catch the last part of what you said, Brittany.
How did you know that the 2 was going to be negative in 2 square root 7?
How do I know if the 2, this guy here, is going to be negative?
The one that's on the top above that, because it was plus minus 7 or plus minus 2 root 7.
Yeah.
So how do you know that it's going to be like which one?
Well, you get two answers, one plus and one minus, so you write both down. It doesn't really matter who you put first and second.
Oh, it doesn't matter?
No, it's the same two guys.
Okay.
I sometimes I just put the plus first, and sometimes I don't. I put in this case, the negative one first. Right, in this case, 2 squared. Oh, darn it. I can see what I've done here. Aren't we going to get a really weird answer? Let's continue, since I did it. 2 squared, take away 4 times 3 times 10. That's going to be 4, take away 120, which is negative 116. So our answer is going to be negative b plus or minus the square root of negative 116 over 2 times a. So it's going to be negative 2 plus or minus this weird square root over 6.
Isn't that 3 be negative 3?
Which one?
For A.
Oh, wait a minute. Well cut. Let me go back to the original question. I'm getting distracted. My little doggies want in and they are scratching at the door. Right. I forgot in the distraction of my household that you shouldn't have written it that way first. That's going to make life a lot different from the answer I just gave a minute ago. I hope. So, b squared take away 4ac, the discriminant, is negative 2 squared take away 4 times a times c, and that's 4 and what, plus 120. So I guess that's 124, which is at least usable, right? So x is going to be negative b plus or minus the square root of 124 over 2 times a. It's going to be the negative of that guy, which is 2, plus or minus the square root of 124 over 6. Can you tidy up the square root of 124? Can you think of anything that works with 124? Because I can think of some. I'm just going to check if I might have something better than that. No, okay.
231.
That's the right one. So you get 4 times 31, so it gets you 2 root 31. Can you now divide everybody by 2? Technically, if something's over 1, do you really need to write it like that? Can't you just write it like this? 2, 2, 2, right? Divide everybody by 2. Something over 1 is just a something. So there's your 2 answers. I guess that one and that one's your other answer. Quadratic formula, right? How do you solve equations using the quadratic formula?
Shouldn't it be over 3 instead of over 2?
A bit louder, Kaliana.
Shouldn't it be over 3?
Is it?
Because 6.
It's 6. Well, what happened here? Oh, shooting space. Okay. Did you all catch that deliberate mistake? It is over 3. It would have been better without that, but hey, it is what it is. Okay.
I have
Let
a
me
quick question.
bring this back. Question? Yes.
Yeah, a little random, but doesn't deliberate mean on purpose?
Yes.
Like, I keep hearing you say it's a deliberate mistake, and I'm like, wait a minute.
I'm trying to be funny and not being very successful. It's just a careless mistake, but I figure out if I say deliberate mistake, at least for the first couple of times, the students might believe me. I think by the time we get to week 6, you know it's just a mistake, right? The only justification, and that's not really a good word, but my brain is 2 questions ahead of what I'm writing. And sometimes that causes all sorts of havoc with not paying attention to what's in front of me. For instance, right now, my brain was already thinking of the homework questions and what's on them.
So I had a quick question with that one. So
Yeah.
The answer for that is actually, it's 1 plus, you don't need the 1, so just
Well,
1
not
plus
really.
the
When I
square.
fixed it, you did need it. Yeah.
So
When we fixed it, it was a 3 in the bottom, in which case it did become important.
Okay, so it's 1 plus 1 square root 31 divided by 3. And
Yeah.
then the reverse of that.
Yeah. One change to that. You don't need to say 1 root 31. You can just say root 31.
Oh, okay.
Yeah. I thought you were talking about the bottom one, which doesn't exist anymore. But yeah. So it's just 1 plus root 31 over 3 and the reverse of that. That would have been the correct one. Okay, let's have a look at what the heck's going on in the homework. I'm going to zoom up to the top first, and then we'll kind of scan through in case I've missed some stuff. Right, the standard form of a quadratic equation. If you rearrange this guy to be in its standard form, one of these is the right one. Can you see, looking at that, would you agree? I'm just double checking, would you agree it would be that one? And that's what I didn't do in one of our earlier questions, and you need to if you want to think it work. In this question here, you're not solving it. Do you know, you're just basically writing down who A, B, and C is. So if you're wondering what's been asked of you, very little. In this question here, wouldn't A be 1, B would be 15, and C would be 5? And in this case here, A would be 10, and B would be -1. C wouldn't be 10. When you have to move it over to the other side, and it would become -10. So that's what we have here. And then pretty much the same kind of question. Solve these quadratic equations using the formula, right? Using the x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And when they talk about a comma separated list, can we just pretend that the answer happened to be really nice numbers for this one? It would go 4, 1. That's what they're talking about. So you don't say x equals and then another x equals, you just put x first number, comma second. It's more likely that your answers are going to look something like this. 4 takeaway, and I'm not saying this is the answer to this one, I just want to show you what the form would look like. You'd have one of them that look like this, and then the other one would kind of look like that, right? Now, when it gets really ugly, you might get an answer that looks something like this. Okay, so can you imagine, depending on how pretty the numbers come out, couldn't you get 2 messy answers that look like this, separated by a comma? And it's find b squared minus 4ac first, stick that inside the square root, and then try and make it as pretty as you can. You know, simplify the square root if it can be simplified, divide top and bottom by 2 or 3 if you can see that happening. And you basically, I mean, even something as ugly as that, isn't that really just going to be A is 72, B is -1, and C is -1? Probably some horrendously ugly square root, right? But doable. In this question here, there is the guy, quadratic formula, but just to be different, you know, I'm not saying that's the right answer, but it might be that one, and you just pick the right one. I don't know what the answer to that is until I, you know, went through the math, but that's pretty much how it works. You can see in this one, you know, maybe it's that one. I guess I've got a 1 in 5 chance of guessing right. What do you think I need to do in 11 before it's ready to actually be solved? I need to fix it, right?
Subtract t and 4.
Yeah, so it's going to be, well, in my case, it's t and 9, but it might be in yours, t and 4. So it'd be t squared, take away t, take away 9, right? And then you do your ABC, but this one has something we haven't seen yet. They want the answer to 2 decimal places. Well, go through the same process as you did before, but let's just pretend for argument's sake that one of the answers was 1 plus root 5 over 4. Wouldn't that be the guy you'd plug into your calculator and just give me the answer as 2.34? So you do the same working, but instead of leaving as an exact value, you've got one more step. Grab your calculator and turn that weird square root fraction-y thing into a decimal and write the 2 decimals down here, separated by a comma. Same thing's happening here, but your choices will be from a list, so maybe it's that one. Is question 13 ready to be solved, or do we need to fix it?
Gotta add 1.
Gotta add 1, right. To finish this whole one off, the last one, I'm going to show you question 14. I think, okay, I've got an issue with, I can't find yous. Where are ya? Here we go. So this is a version of the last question. Yours, of course, probably will have different numbers. First thing, if you need to, do that, agreed? Now this question wants the answer to 2 decimal places. So I'm going to take you through how I would work on this. A equals 2, B equals -1, C equals -5. Then I would do B squared, take away 4AC. That's -1 squared, take away 4 times 2 times -5. That guy's 1, add 40. So 41. Okay. So it's -b plus or minus the square root of 41 over 2 lots of A. What's that going to be? Right. If b is -1, won't the negative of b be 1 plus or minus the square root of 41 divided by 2 lots of 2, which is 4. In this particular question, we'd agree that that square root doesn't simplify. So if they wanted the 2 answers that are the exact answers, you would write down that guy, comma, that guy. And that would be fine, right? That would be the answer. You know, you'd have a big box around it and they'd have an x equals here, right? And that's what your answer would look like. Since they want the answer to 2 decimal places, all I do is I go to my calculator and I make sure that I'm careful about brackets. So I go bracket 1, subtract the square root of 41, close the brackets twice, which I didn't do the last time, divided by 4. Okay, what the heck? Try that again. A bracket 1, take away square root of 41, close the brackets, that's better, divided by 4. And one of the answers would be -1.35, comma, and then I could just go back to the other one. Do you know the little trick in your calculator where you can bring back the last calculation so you don't have to retype everything? If you hit second button followed by enter, you can then just scroll and change that to a plus, and it saves you having to retype everything. And the second answer is to 2 decimal places, 1.85. So that would be the answer that they were looking for. Do we feel comfortable that if I gave you a quadratic equation, that you could solve it using the quadratic formula? Whether the answer had to be exact or as a decimal, it wouldn't matter, right? Because pretty much, wouldn't you do it as if it was exact? And if that's what they wanted, you'd stop. And if they wanted a decimal, wouldn't you just use your exact answer to get the decimal? So it's not like you would do much different, no matter what they did. Do you feel comfortable about that guy? I'm seeing at least 2 nods. Okay, we are good. So do you need one to practice on, or should we just call that good? Call it good. Okay. Can we just batter on and get the last one done? Call it good. The last section, everything's done. Let's do that then. The last in our list, 8.3, graphing quadratics. Well, it's got 2 pieces, but most of it is graphing quadratics. Okay. Well, you've probably seen y equals x squared, right? Math 94 or somewhere. You know, that's basically the equation of a quadratic. If you sketch y equals x squared, doesn't it kind of look like that? I'm going to introduce what's called function notation. F of x, that's how you read it out loud. F of x is equal to x squared. That's the exact same thing as that. It's just a different way of phrasing it. Now, why is this notation considered a little bit better than that one. Well, you can do things like this, for instance. If I say to you, find f of 3, do you understand what you're being asked to evaluate here? Aren't you being asked to evaluate 3 squared? So the answer would be 9. We're comfortable with functional notation. Instead of saying y equals something, we can say f of x equals the same thing, and it's equivalent. So here is the general equation of every quadratic in the universe. Right, standard form. Ax squared plus bx plus c. An example of that might be x squared plus 6x plus 9. Now, when you sketch a quadratic, that's its general shape, but there are other kinds of shapes. So let me just take you through some of the shapes that you will get with a quadratic. Sometimes quadratics look like happy faces that don't cross the x-axis. Sometimes quadratics look like happy faces and they just touch the x-axis at one point. And sometimes quadratics look like happy faces and they cross the x-axis at 2 points. Now, those are the 3 basic shapes of a quadratic that has a concave up shape, right? It goes upwards. Since I didn't plan ahead, can you imagine you could have a quadratic that points like this, or points like that, or looks like that? So I guess altogether, aren't there 6 quadratic shapes, basic shapes? If we can narrow down our quadratic to one of these shapes, can't we make our life a lot easier if we want to draw a sketch of it? Or at least compare what it would look like given a choice of 4 or more quadratics. Well, the main important part of a quadratic, right? For instance, x squared plus 8x, I need a number here, minus 3, right? The main feature that helps you to draw a quadratic is 1, its shape, and 2, where the vertex is. If I know those 2 things, I can draw a pretty basic shape of what that would look like. So since I got these guys already drawn, have you noticed that in these quadratics, there's a point that's lower than anybody else? That point there. We call that guy the vertex. In this question here, wouldn't the vertex be here? In this one, it would be here. In this one, it would be here, right? So these are where the vertex is. Now, what do we mean when we talk about the shape? Well, different textbooks have different names for the shapes, but there's 2 basic shapes. These are not mathematical terms I'm about to use, but I use these terms very often. Happy face and sad face. Right? And now the reason I like those terms is, can you kind of visualize which shape I'm talking about if I say it's a happy face? If I say it's a sad face, can you kind of visualize it? Now, you can't use those terms in an academic way, but you might want to think of those terms just for your own personal use. They do have names, but the official name of them depends on which textbook you use. But this fella here is called concave up, and this fella here is called concave down. And there are other names, but I'm using the ones that I'm familiar with. So a happy face is concave up, and a sad face is concave down. If you're down and miserable, aren't you sad? I'm just trying to put a story to help you remember the name, right? If you're down, aren't you kind of sad? And if you're up, aren't you kind of happy? Because you're going to get a question, not maybe that term, but I can imagine you might well get a question saying what shape is it, and you've got a choice of concave up and concave down, and you can't remember which one is. Would that maybe be a way of remembering the details? Now, the vertex is this point here. So this vertex here might have coordinates 1, 2. This vertex here might be 2, 0. This vertex here might be 3, -4, right? But if we have the coordinates of the vertex, don't we pretty much know everything you need to know? So I'll give you an example. Suppose I tell you I've got a quadratic and its shape is a happy face. And I tell you that the vertex is at coordinates 1, 3. And that's the only thing I tell you. You should be able to draw a very rough version of that shape. Wouldn't you go to the position 1, 3 and put a little dot? And since it's a happy face, wouldn't you draw your quadratic like that? Agreed? So if you tell me the shape and you tell me where the vertex is, don't I have enough to draw a very basic shape of any quadratic you could probably give me, right? Tell me its shape, tell me where its vertex is, and we are good to go. So let me show you how you actually get that information. Let's talk about shape first then. To find the shape of a quadratic, use the coefficient of x squared. And this is how it works. The number next to x squared is called the coefficient of x squared. If this number is positive, in this case it's 3, right? So if a is 3, you are going to get a happy face. And if this is negative, you're going to get a sad face. Would you agree positive is good and good is happy? Would you agree negative is sad and sad makes sad faces? Is that a way of trying to remember? Positive happy faces, negative sad faces. I don't care how big that number is, I only care it's positive. I do not care how big this number is, I only care that it's negative. Right. So concave up, concave down. So far, so good. Now, that's kind of the first puzzle, right? How to get the shape. The second piece of the puzzle how to find the vertex. I'm going to write a quadratic, not in its usual form, but in its completed square form. Now we've done that, so it shouldn't be too hard for us to take a quadratic and write it like that. When it is written in this particular version, right? When it's in its completed square form, we can get the coordinates of the vertex. You get them from these two numbers. The x coordinate is 3 and the y coordinate is 1. Now, unfortunately, there's a difference between these two. Do you notice that that says x negative 3, but the 3 is the x coordinate? Do you see how that's 1, but the y coordinate of the vertex is 1? So in this one, it changes, in this one it doesn't, right? So there's a little back and forward thing going on there. So let's just practice that guy. I'm going to make up some quadratics, and they're already going to be in their completed square form. Okay, and we should be able to figure out the coordinates of its vertex. So let's see. I'll put them over here. What's the x coordinate of the vertex of this quadratic? What number is it?
2.
And what's the y coordinate?
3.
Do you see what I'm getting at? This changes and that doesn't. You see how this one is a different sign, this one doesn't change? Right, in this case here, wouldn't that be 2 negative 3? What about this one then? What's the x coordinate of this guy's vertex?
-5, -1.
And -5 plus 1. Are you getting a little bit more comfortable that if it's in its completed square form, are you a little bit more comfortable about finding the coordinate of the vertex? Great. Now, each one of these guys, you're going to trust me, but see if you foiled these guys out, aren't they all going to be plus x squareds? So doesn't that make every single one of these happy faces? They're just happy faces at different vertexes, right? So what would a completed square version of this look like if it was a concave down, a sad face? Well, really only one change. See that negative there? That makes it a concave down. That makes that a sad guy. See this negative here? That makes that guy a sad guy. Concave down. So if you get a quadratic function and you're trying to figure out what does it look like, find its shape, concave up and down, complete the square, and that should allow you to get its vertex. So I'm going to put that into practice and try a very basic sketch. Oh, by the way, see the questions that you get 4 pictures and your job is to pick which picture, right? So that's how they're going to get by the drawing part, right? So here is my quadratic that I want to do a sketch for. Okay, concave up, concave down. What's the shape?
Up.
Happy face up. Completing the square. Forget about that side. Just focus on completing the square, right? Isn't that half the number of x's, square and subtract? Right, we've done a lot of those now. Half the number of x's, square and subtract. Do you see what we've done is we've taken the standard version and rewritten it as a completed square. But Won't this allow me to get the coordinates of the vertex? What is the coordinates, the x coordinate of this guy, vertex? X coordinate of this guy.
-3.
And won't the y also be -12? Now, can you imagine that I plotted the point -3, -12? And we want a happy face guy, don't we? So can you imagine my guy would look something like this? Now, it's not the best sketch in the world, but it doesn't to give you a rough idea of what the thing looks like if you've plotted it. Now, do you notice this vertex? If I draw it, well, it goes through the line x equals -3. This line, this vertical line, is called an axis of symmetry. So if you had a vertex, like, let's borrow this picture. Can you see the vertical line down the center of the shape goes through the x coordinate? This is x equals 1. That's what you call this dotted line. And it's called the axis of symmetry. Because quadratics are meant to be balanced, right? Either side of the thing should be roughly the same, right? It should be a nice symmetric smile, right? How are we going with this? We good? Right. Try another one. Half the number of x's, square and subtract. Won't this be a happy face? And won't the vertex have coordinates 4, -18? If I was going to do a sketch, can you pretend that this point here was 4, -18? And I draw a happy face, and going right down the center of that would be our axis of symmetry. I'm going to give you a quadratic, and I want you to try and do essentially what happened here. So there's your guy. Okay, here goes. Oh, wait a minute. I may not be on the right place here. We're on it. Okay, I think we're on it. White screen. Okay. Completing the square. Half the number of x's, square and subtract. So you're looking at a guy that looks like this. Would you agree it has a vertex at -5, -15? And it's yet another happy face. So -5, -15. You can imagine might be somewhere about here, happy face. And going right through the center would be the axis of symmetry, and its equation would be x equals -5. Now, it's not a perfect shape, it's not meant to be. It's a kind of rough and ready shape, but it gives you a good idea of what the thing would look like. So let's have a look at the homework associated with that part of the class, the section. I believe it's this one. Okay. Question 2. Look at this graph. The lowest point on the graph is 2, -1. Agreed? What's that point called? That's how simple this question is. I hear your mouse moving. Vertex. Right. Question 4. Here is a concave down guy. What is the vertex? Well, what they're asking really for is the coordinates of it. Would you agree it's here? So if I count the boxes right, 1, 2, 3, it looks like it's 4, 5. I pick that one. Right, nothing too strenuous yet, right? Just a matter of getting you warmed up really slowly. Okay, I have to still show you that. Okay, we'll come back to that. This is question 10. And do you see this function is already in its completed square form? What's the coordinates of the vertex of this guy? Well, let's do it this way. What's the x coordinate of the vertex? 2. What's its y coordinate? Because there doesn't seem to be a plus number at the end, does there? So 2, 0. And the only one that's 2, 0 is that picture. Great. Now, if I scroll a little bit further, oh, well, we can't do these ones because, well, we could, but it would take time. Can you imagine completing the square and getting the answer? They call this upwards and downwards. So upwards is happy face and downwards is sad face, right? So that's just their words. So can you imagine what you're going to do is the coordinate of the vertex. I'm pretty sure the answer is 2, something. I'm not sure what the something is because I haven't done it in my head, right? But couldn't you plug in, let's pretend it's 2, 3, plug that in. And then wouldn't the axis of symmetry be x equals 2? Wouldn't this one be, oh, will this one go up the way or down the way? Will it be a happy face or sad face in question 12?
Sad.
Sad. How do you know? You're right. How do you know?
The -x².
Okay. Complete the square. Oh, okay. They're telling me what to do. Wouldn't you complete the square on this guy and figure out which one it was? Right. Okay, that's something we haven't done yet. Some stuff we still to do. Okay. Let's move back and show you some more things. I'm going to try and show you that there is some shortcuts we can take. would you agree that sometimes completing the square can be quite awkward, especially if the numbers are a bit on the big side? Right? So there is, in fact, a shortcut for getting the vertex. It's really useful when the numbers are awkward, or if it's a sad face one, because negatives are very hard to do what we have. So here is a quadratic, and I would like to get the coordinates of its vertex, right, without doing too much work. Well, the x coordinate of a vertex, or of the vertex, is given by negative b over 2a. Now, let's remind you, in this question, isn't a 1, b is 4, and c is negative 7? You agree? If I can use this, shouldn't I be able to get the x coordinate of the vertex? So let's see what that gives me. The x coordinate of the vertex is negative of that, divided by 2 lots of that. The x coordinate of the vertex is negative 2. Do you see I didn't need to complete the square to get that? But that's only half the problem. Don't I still need to find the y coordinate of the vertex to be able to help sketch the shape? Well, that's a nice shortcut, right? You got the x coordinate, don't need to complete the square, which can be really messy. But how am I going to find the y coordinate using this? I know the x coordinate is negative 2. How am I going to find the y coordinate? Need some help? Okay. This is the functional notation way. Isn't this the same as that guy? Isn't that just another way of saying it? Now, when I write it this way, it's a little bit clearer that what you're finding is the y coordinate for a given x. And if x is negative 2, won't the y coordinate be negative 2 squared, 4 lots of negative 2, take away 7? That's 4, take away 8, take away 7. And that ends up being negative 11. So there we have the vertex. You get the x coordinate by using this formula. Once you know the x number, you basically plug x in here, and that will be the corresponding y coordinate. Is this shape happy or sad? Happy. Can you imagine I put this together? Couldn't I draw a pretty quick sketch of what that thing might look like? It would be somewhere down here going up the way. When this shortcut or this trick becomes really useful is when you've got something that's really ugly. Take that guy. Would you agree that is not a good guy to try and do completing the square on? In fact, I'm not quite sure you'd even know where to start. But we can get the x coordinate of the vertex. In this question, a is negative 2, b is 4, and c is negative 1. So negative 4 over 2 lots of negative 2, which is, negative 4, which means the x coordinate is 1. Right? The x coordinate of the vertex is 1. And if I want to get the y coordinate, don't I just plug in 1 here? So what's that? 2 lots of 1 squared plus 4 lots of 1, take away 1. That's 1, so that's negative 2, add 4, take away 1. Oh, this is weird. Also 1. So the vertex is 1, 1, right? That's my vertex. Happy or sad face? Is this quadratic going to be a happy or a sad face? You can look sad if you don't want to tell me. Don't look happy. That's the wrong answer. Look sad if you want to show me the face or tell me. Which is it? It's sad, right? So can you imagine I plotted 1, 1 and went sad on you? And right down the middle, right? Isn't the x equals 1 the axis of symmetry? Because in a lot of the questions, they ask you for the vertex, they ask you for the axis of symmetry, and then they give you some pictures and you pick one. So if I gave you a quadratic, do you feel comfortable you could tell me happy or sad, and where the vertex is, and what the equation of the axis of symmetry is, and then put the whole thing together to draw a very basic picture? You feel comfortable you could do that? Okay, you're going to prove it to me because I'll give you one, right? Find coordinate of vertex, happy, sad face, axis of symmetry equation, and a very basic sketch, right? Do the whole kit and caboodle, right? Start to finish. Okay, I'm ready to get started. Hopefully you are close to being finished. Let's, in no particular order, let's get the x coordinate of the vertex. So it's -6 over, oh, I thought I'd done that. Okay, 1's a good answer. I wish I'd give you some a little bit messier, but 1 will do. The y coordinate is -3 lots of 1 squared plus 6 lots of 1 take away 10. At least that's a bit messy. I believe the answer is -7. You want to back me up on that? Okay, so we know the vertex. It's at 1, -7. Is this a happy or sad face? Happy. Oh, you're showing me a sad face. That will do. Sad face, right? The fella here tells you. Won't the equation for the vertical axis of symmetry be x equals 1? It's the same value as the x coordinate. Now, as a very basic shape, can you pretend that that's 1, -7? And can you imagine a sad face somewhere down here? And a little axis of symmetry through the middle of it. So that's the kind of shape that you would have. We feel comfortable then about this basic shape, right? So where are we off to next then? Well, I'd like a better shape. I'd like a more accurate sketch, right? Essentially. So if I'm going to do a more accurate sketch, I guess what I need are some more points on the curve. Right now, I know how to get the vertex and I know how to get the shape, and that's about it. Right? So here is a detailed sketch. So I'm going to go x squared plus 8x, take away 9. And I'm going to go through a kind of checklist of all the things that you need to find if you want a detailed sketch of a quadratic, right? Rather than a simple sketch. So the first thing you're going to go is you're going to find out what the shape is. We know how to do that. Would you agree this is a happy face? Second thing we're going to do is we're going to get the vertex. So we're going to do the first 2 steps that we always did. Now in this particular question here, isn't the x-coordinate of the vertex negative b over 2a, negative 8 over 2, it's negative 4, agreed? And the y-coordinate then is negative 4 squared, 8 lots of negative 4, God in himmel, take away 9. So what do I get? I get 16, take away 32, take away 9. I believe I get negative 25. So the vertex is going to be negative 4, comma negative 25. Does that look correct? Okay. So that's step 2, get the vertex. 3, get what's called the y-intercept. The y-intercept is where a curve cuts or crosses through the vertical y-axis. And it's not that hard to find. If you want to find out where something crosses the y-axis, don't you basically just find out what it's equal to when x is 0? Because 0 something is the y-axis. And that's even easier, isn't it? Just the number negative 9. So the y-intercept will be at 0, comma negative 9. In fact, I'm going to start putting this information together over here. And you're just going to pretend this is square paper. So at 0, negative 9, we've got the y-intercept. At negative 4, can you pretend the way down here is negative 25? We have got the vertex, so I know it's coming round like that. Right? Can you kind of imagine what's going to happen here? Isn't it going to go this way and then it's going to go that way? And isn't it eventually, somewhere, it's going to cut the x-axis, agreed? It's going to cut the x-axis somewhere over here and then another place it's over here. That's the last thing that we find. We get the x-intercepts. I'm going to put my quadratic fillet over here because I need a bit of room. If you want to find out where a quadratic cuts the x-axis, what you do is you solve that quadratic equation. Because basically what you're doing is finding out when the y-coordinate is 0. Now, this guy, thank goodness, factors. Have you anybody got 2 numbers that multiply together give me negative 9, but when I add them I get plus 8? There are 2 numbers out there that do that.
9 and negative 1.
I got it in at least 2 locations. Perfect. So, to continue, doesn't that give you an x-intercept when x is negative 9? And doesn't this one give you an x-intercept at 1? So can you imagine that's 1, and that guy over here is negative 9, which kind of looks right. If you look at the other numbers, doesn't that look about the right kind of values? And then you basically just keep going and keep going. Do you see that this shape is a little bit more accurate than happy face? Because couldn't you do a skinny happy face and a big fat happy face? It could go all over the place. Can you see in this case you're kind of restricted because you have to cross the y-axis here and you have to cross the x-axis here. So essentially you just add in 2 extra things. Where does it cross the y-axis? Where does it cross the x-axis? And that's how you would do a detailed sketch. Is it that extra, or do you think it's not too hard to just add a few more, a few more data points and join them up? Right. Find a y-intercept, find a couple of x-intercepts, should be good to go. Right. So I'm now going to return to the homework, and we'll see how this goes. No, it won't. If you hold with me, for some reason, I don't have the thing handy. So I'm going to have to reset it. Okay, I'll stop sharing and then I'll start sharing again, and this time we should see it. I think it's here. Are you looking at the formula, the homework? Yep. Is it a nice big homework? The whole page. Right. Okay. Question 16. Find the x and y intercepts. Now, do you see they're just asking you to do what I've called steps 3 and 4, right? You're not going to draw it. You're not going to find the vertex. You're just going to find the x and y intercepts. Okay. Look at the y-intercept. Would you agree it's at 0, negative 63? Agreed? 0, negative 63. Aren't there going to be a small x and a large x, right? One of your x's is going to be negative 2, the other's going to be 7, right? One's small and one's big. So in your head, that's a bit tricky, can you factor that guy? Because it is possible. 2 numbers will give you negative 63, but when you add them, you get negative 2. What kind of 2 numbers are we talking about here?
Negative 9 and 7.
Okay, so can you imagine you factored them? Wouldn't they tell you what the x is 9 and the y is 7 or negative 7, right? Get the signs right. And all you do is, I can't remember which one it is, but you can check it later. Won't it be 9, 0 and, oops, wrong one. Plus 7, right? So 9, x, I'm trying to do this in my head. X minus 9, x plus 7. X minus 9 is 9. X plus 7 is... Yeah. Can you see that's how you would write down your answer? Y-intercept, in this case, you would just tell me it's 0, negative 63. And you're done. That question would have been much more interesting if they'd actually got you to do the vertex as well and the shape, because once you've done that, haven't you got everything you would possibly want to draw the thing? 17's essentially the same question, 18's the same question, 19's the same question, right? So you're just going over and over and doing the same thing. Now let's look at 20. Determine the coordinates of the vertex and then use it to figure out who this guy would be. So then determine the x and y intercepts and finally plot several points and complete the graph. Okay, if you were looking at question 20, you're basically going to go through the whole process. But at the end of the day, isn't it just going to be one of these 5 pictures? So you might do an awful lot of work, and I don't want to do this in my head because it'd probably take me forever, but can we pretend that that's the one that worked? Then that's what you would tick. So you are going to take this fella here, and you're going to find its shape, concave up, right? Happy face. Oh, I can already cut out a couple. What is the y-intercept of this quadratic? Where does it cross the y-axis? 9? 9. So can't I forget about that one, because doesn't that cross it at 4? It might be this one, right? It could still be this one. Won't I forget that one? And won't I forget that one? Do you see I've already narrowed it down to just, what, these two, right? Couldn't I get the vertex or maybe the x-intercepts, and that would probably decide which of the two that's left? So it's like solving a crime. You're given some clues, and your job is to find out which graph did the thing, right? Which graph committed the crime. Question 21 is the same puzzle, right? They give you one quadratic and 5 pictures, only one of which is the right one. Question 20, are you getting deja vu here? Question 22 is the same question again, but just, you know, different function. And now we're on to our last puzzle. I think we're going to get it done. Is our brain still functioning? Because mine is beginning to wind down here. Are we still in the game? Okay. We are going to look at applications. Thank goodness there's only, I think, 3 of them. So it's not going to take us forever. And I'm going to go through every single one of these because you don't get a lot of practice. And the questions that you've got in your homework will be similar, but they'll be different numbers probably. So even if I do that, I'm not doing your homework question. I'm just doing one similar. So we're looking at question 23. And they've got a guy who is at the top of a building and he throws a ball and they tell you some stuff. And the formula that you end up is S. And it's equal to negative 16t squared plus 32t plus 48. And I'm drawing a little picture of what this looks like because you won't see it in a few seconds. And the question asks us, give the height S of the ball t seconds after it's thrown. Find the maximum height. Okay. So here goes. This question feels to me a bit like something you might get in a physics class. You know, John threw a ball in there and how many seconds was it in the air and what was the maximum height and things like that. So here goes for the first one of our 3. Ball goes up, ball comes down, hits the ground. They tell you that that's, actually I believe they tell you, yeah, they tell you that's 42 feet. That's meant to be a building. Right, that's a building. Really all we need to do is look at this fella. Can you see that this is already a sad face? There's bits of it that don't exist, but if you kept on going, can you see the rest of the sad face down that side? Right. If you want to know the maximum height, isn't that just saying, tell me the vertex? Isn't that the bottom line? Tell me where the vertex is. So I am going to take this guy and find the coordinates of the vertex. I do not want to do completing the square. So can't I use my little cheat that we did earlier? Technically, it started off as x equals minus b over 2a, but it's not difficult to kind of change the letter. Won't it be t equals negative b over 2a, because it's a quadratic, that is t's, not x's. In this question then, what number is b, and therefore what would negative b be equal to? So up here, what's b? 32? So b would be the negative 32. And won't a be 2 times, oh come on, I'm getting tired of ones. Isn't t equal 1? Now, I would normally say y equals, but in this case, won't I just say s equals? And it's negative 16 times 1 squared plus 32 times 1 plus 48. That's negative 16, that's add 32, and that's add 48. So it looks like 1660. And the question, I believe, had 2 boxes in it. And the first box wanted to know the height, and the second box wanted to know the time. The time was 1 second, and the height was 60. And that's the end of that puzzle. Are we good with that? Are we cool? I'm going to move on. Any questions? This is your chance. $24. I can read 24, so you're just going to trust me. Suppose you're a police patrol officer and you have 270 foot of that yellow stuff that they use that says do not cross. Isn't that the thing they put round when there's dead bodies and things as well, right? So what do I have? In this story, I have they box in an accident, and the total is equal to 272 feet. And they ask you a question that looks impossible. What are the dimensions of this rectangle to maximize the area? So we want the maximum area. Now, when I look at this question, it looks like you're missing some details. You think, I need more information before I can solve that. But that's not going to actually be the case. So let me show you how I'd approach this. If you don't know what something is in math, don't you typically just give a letter of the alphabet? So I'm going to call that X. And I don't know what that guy is. I'm going to call it Y. Would you agree that the area is X times Y? Right? X times Y. So my quest here is to somehow figure out a way of writing down Y in terms of X. And if I can make that happen, won't I be able to replace this Y with some stuff with X's in it? And then I might be able to figure out the best maximum area. Now, the only thing I know is that the total going around the outside is 272. Now, if you think about it, isn't the total made up of 2 X's plus 2 Y's? That makes sense? Now, if I try and solve for Y, I would subtract 2 X's from it. And then what would I do to find Y on its own? What would be the thing to do to both sides to get Y on its own here? Two Y equals this mess. What would I do to get 1Y equals? You might be saying something, but I can't hear you.
Divide by 2.
Divide by 2. Now, if you divide this by 2, I believe it's 136 take away X. Ah, wasn't that actually what I was trying to do? Wasn't I trying to get Y in terms of X? Well, I have. Isn't Y this guy? So won't the area be X times 136 take away X? If I distribute that, isn't it 136X take away X squared? Do you recognize that as a quadratic? If I write it this way down, I don't know if it helps or make it look worse, but isn't that the quadratic? Agreed? Where do quadratics get their biggest answer? Because that's a concave down. So where do they get their biggest answer? Oh, they get it at the vertex. Have you noticed there's a theme here? Isn't every question about finding a vertex for whatever reason? Well, let's go hunting for this guy's vertex. The A is -1, the B is a horrible 136, and the C isn't there, so I guess it's 0. The X coordinate of the vertex is -B over 2A. The negative of that over 2 lots of that ends up being 68. So X is 68. That will get me that vertex. That makes this X 68 then, doesn't it? The question doesn't want to know what the biggest area is. The question just wants to know what the dimensions of the rectangle that would make that happen. Haven't I now found that the x value is 68? So here's the little bit at the end that might catch you. I need to know what the y is. The temptation is to put x equals 68 in here. But see, if you do that, you won't be actually finding that distance. Won't you be finding the area of the big rectangle? It's this guy over here I'm going to use. Isn't this guy the guy that's going to tell me what y is? So it's a little bit different, right? We're not using the y coordinate of the vertex. That would be the biggest area. It's the y coordinate, meaning this distance. And if you put in 68 here, something really remarkable happens. And then once that happens, you think, of course it is. What's special about that rectangular cordoned off area? What's special about that? Look at the two numbers. What's special about it? It's a
Perfect square.
If you think about it, wouldn't a perfect square be the most efficient area you could get if you only have so much stuff, right? I'm making this up, but I think it's probably true. See if you're a farmer in the middle of the, you know that bit where you put up a temporary fence so you can collect all your sheep so you can inoculate them or whatever you want to do to them. It wouldn't surprise me that he brings one of those mobile fence things. It wouldn't surprise me if he always makes a square. Even although he didn't know the math behind it, wouldn't a square be the best, most efficient shape? And it is actually. And we've just proved it. 68 by 68. So your answer in this question would be 68 for one of the numbers, shortest side, I guess, 68 for the longest one. And suppose, they do. Suppose I want to get the area. Don't I plug 68 in here and that'll tell me what the area of this is? Actually, I'd probably go 68 times 68 because it's less work. And that's the second of our three. And so this is, there is a river down here. And the farmer is using the river to save some money. He's only fencing 3 sides. And he has got 1,400 feet of fencing. And we're being asked the same question. What should the sides be, right? How big should he make, this direction? How big should he make that one? Hopefully this is deja vu. I do not know this side. Can't I call it X? And I don't know this side. I'll call it Y. Won't the area, right, the whole thing, won't the area just be X times Y? So far, so good. Now, he has got that much fencing. Won't that be 2 lots of X, but only 1 lot of Y? Not quite the same as cordoning it off, because in the first one, didn't you have to cordon off all 4 sides? But in this case, you only need to do 3 sides. Now, if I rearrange this one, would you agree that it's not that difficult to get the Y in terms of X that we needed? And so I can go here and call this X 1400, take away 2X, distribute the X's. And I don't know if you need this or not, but I've started, so I'm going to finish. Can you see the quadratic? And can you tell it's one of those guys? And can you tell that the vertex is what we're after? Right, the X coordinate that is that vertex. The top of the hill is the biggest area, and that's what we're after. What value of X gives me the biggest area? Well, the X coordinate is negative B over 2A. It's negative 1400 over negative 4, which should work as 350. Please tell me I've done that in my head right. Is 1400 divided by 4 350? Okay, great. So this guy here is 350, right? Actually, so is that guy. Where will I find the guy to use to find out the y side? Will I use this guy with 350 in it, or I'll use something else? This one. And the y is 1400, take away 2 lots of the x. The y is 1400, take away 700, and the y is 700. And when I look at this picture, it's not a rectangle anymore.